All right, if you hear crunching, it's because I'm eating my lunch. Okay, now to be totally honest with you, I haven't had a chance to check whether they're asking you to do this or not. So make sure, don't use this as your instructions. These are just to help. But one of the things you generally want to do is you want to check normality. So remember way back when you were learning statistics, you found out that different statistical processes have rules about what's appropriate and what's not. And one of the things is that you generally want your data to be as normally distributed as possible. So if you remember your bell curve, you want it to be as normally distributed as possible. So one of the things we're going to check is the normality on these two new variables. I haven't created the others, but you'll get the idea. So we're going to go Analyze, Descriptive Statistics, Explore, and let's just get our new variables, Independence and Co-workers. So you can do two at a time, that's not a problem. You can do all of them if you want, it just gets a bit confusing. Statistics, we want outliers, and descriptives. Plots, let's have a histogram. So I think the default is stem and leaf, but a histogram's a bit more useful, in my opinion. Normality plots with tests, continue. Options, exclude cases pairwise, continue, don't worry about bootstrap, and then press OK. Okay, so what you'll find here is your normality data. So remember, we want it to not be too skewed. So one of the first things we're looking at, and this will be a dim, dark, distant memory from first semester, I imagine, is it skewed? So what we want to know is that if we get the statistic, the skewness statistic, divided by the standard error, is it greater than 1.96? So if it's greater than 1.96, then we need to do something about it. So if you think double, okay, so is 0.268, whether it's negative or positive is irrelevant, is it double 0.175? Okay, no, obviously not. However, co-workers, negative 0.507, so we have a negative skew, is more than double 0.175. So we might want to do something about this. Now, to be totally honest with you, I don't remember whether the instructions have actually said to you that you can leave it alone or not. So you need to actually have a look for yourself. This assignment is all about you taking control of your research. It's not about us telling you what to do. So you need to look this up and work it out whether you want to do this or not. So this means it's skewed. It's got a negative skew. You've all heard that kind of thing before. So we want to see what we can do about it. Now, I'm not sure where you'll find information about dealing with skew, but Tabachnik and Fidel certainly has some, but I'll show you how to deal with this one. Again, if it's not included in the content, don't stress about it, just ignore it. Ignore my instructions. So what we're going to do is we're going to transform this data to see if we can make it less skewed. So we're going to go transform, compute variable. Same kind of process we did when we were adding them up. Okay, so we're dealing with co-workers. So we're now going to go co-worker underscore tr for transform, just so that you can keep a track of which one's which. And what we want to do is we're going to do, because it's only a small skew, so it's only a little bit more, is we're going to do a square root transformation. So sqrt, brackets, and then because it's negative, we need to turn it around the other way. So we have a look at the maximum. So the maximum is a maximum score of 20. So we go 21 minus that score, co-worker score, okay? So because it's a negative transformation, we can't just go square root multiplied by co-workers. Because it's a negative transformation, a negative skew, we actually have to get the maximum, add 1, and then minus co-workers, okay? I hope that makes sense. Again, if the instructions say don't worry about skew, don't worry about skew. Okay, so in theory that might fix it, but we're not sure. So now what we need to do, so we've created a new variable. So when you scroll down here, it's got compute co-workers, so syntax again, and we want to know whether that actually worked. Explore, so get rid of these ones, put them back, and then down the bottom you'll find this new variable. You can ignore all of this because that's going to hold the same stuff as before. And we're going to have a look. Negative 0.14, 0.175, so it looks like we fixed the skew. So it's no longer skewed. And then when you have a look here, yeah, the numbers are different, right? But it's no longer skewed. So it's now between 0 and 0.36 or something. So it's not going to look quite the same, but the distribution is the same. So have a look around, see whether they want you to deal with skew or not. But if you do need to deal with skew, that's how to do it. Tabachnik and Fidel has some instructions on how to deal with bigger skew than the small one that we just dealt with. But you may not need to deal with it. I'm just putting it in here just in case. So good luck.